So today I'm going to help you create a aerofoil in Solidworks. So the first step, we need to make sure we look at Stewart's aerofoil analysis slides. Firstly, we need to now consider what NACA profile. So there's some information on the screen scrolling about the NACA aerofoil types, and most importantly for us is where do we get the NACA profiles from. As you can see here, I'm highlighting the University of Illinois website. If we go into that website, we can then search the full NACA database. So we're being recommended a 4415 profile. So we'll go to the website and we can just do a Control F and we can just type in what we want. So from that we'll get two options. I'll open them as new tabs for us to have a closer look. Firstly, we have the profile itself. So if we are looking for a specific type of shape, if we want to look for a low drag profile, we can look first, and then secondly we have all the data. We can at this point copy the data directly from this web page and then import it. That is an option. I would recommend that we right click and then if we save the link as, what that allows us to do is save it locally as a DAT file. You can see I've already saved it. Make sure we save it as a DAT file is the key point. Okay, so next up for us, we need to now take that data into Excel. So if we load Excel, we just need to go onto File, then Open, and if we select that DAT file, it will give us these options you can now see on the screen. Now what we have seen in the DAT file is it's actually in a single column. We need to separate it. So if we press Next, separate by space, you can now see it splits that into two columns. We can then press Go, and then all of a sudden the data is given to us in two columns. Great. So, couple of points. We need to make sure that only the data is saved. So we delete that top line. And then what we can actually see is X data in column A, Y in B. Now actually we need to make sure we add Z. Now for us we're going to import this in 2D, so Z is always 0. So in this case Z is always 0. And then we look at the bottom and we make sure the profile is closed. And we do that by making sure that the end is the same as the beginning. So now we can save this file. And again, it's important to save it as a DAT file as highlighted on the screen. So with that now saved, we are ready to import into Solidworks. So if you open Solidworks and you create a new part, we now need to import that data. So I've already got the surfacing tab added. So if you see on the end on curves, I then just need to insert. So I've made a mistake here on purpose to showcase a point. So if you find the DAT file, we open it. So we have to change the settings to find it. Open that DAT file, come up with an error, and the error is because we've left it open in Excel. You're all going to do the same thing. So that's why I left this in the video. So let's make sure that the file is saved in Excel. We'll close that down. And now let's try again. So we just need to try and find in my case downloads, find the DAT file, open that, and it's imported. So we can see X, Y and Z coordinates exactly the same as what we had in Excel. When we press go, we can barely see it, and that's because I'm in millimeters, so I've imported an aerofoil in millimeters. So if we zoom right in, we find our profile. You probably all have Solidworks set to millimeters. That's okay, we can correct it to be in a more appropriate unit later on. But now we can see we have the sketch outline of the NACA profile. If we go to front plane and create a sketch, and then we can convert the entities of that NACA, we then have it as an actual sketch. Now it's something which we can physically work with on Solidworks, which is great. I'm just going to go ahead and hide this import. So now I'm working with a true sketch. So there's a few things we need to do first. First step is we need to make sure that we add a construction line from the very trailing edge to beyond the leading edge. Notice that I made sure that line was completely horizontal. So if we press for the end of that line, hold control and then press on the aerofoil, we need to make that coincident. It doesn't matter about the dimensions the aerofoil jumps to at this point. What's really important is the aerofoil should not have any connection to the initial origin in Solidworks, otherwise we are unable to work with it and move it, as we can see. In this case, we keep that critical chord dimension as horizontal. That allows us to work with it for the next few phases. So perpendicular to the chord line, we'll add another line. We just make sure that we've got the right connections perpendicular, and it also needs to be at tangent to the aerofoil itself. Now we should be able to move our aerofoil in single directions only, keeping an eye on those dimensions. So if we remove those dimensions, what it would allow us to do is change all of these different directional aspects, changing the angle of attack. So at this stage I'm going to now change my measurement to be in meters, so I have a 1 meter chord aerofoil. We can adjust that to whatever size we might want at a later point. So NACA profiles are aerodynamic devices, and aerodynamic devices are normally there to generate lift, which is not a function that we would normally look for in a race car. So I created a line, which is another horizontal line. Make sure it's absolutely perpendicular with our chord. Now what I'm trying to do now is I'm just going to mirror the aerofoil and the construction lines. So now we have a downforce generating aerofoil. From that point I can just highlight all the bits now which I initially imported because I don't need those, and I can delete them. Now we have a downforce generating aerofoil. I just need to re-add those relationships again, because unfortunately they didn't carry over. So just be careful, make sure you get the right relationships re-added. And now we can check to see if it moves in the same way as before. It's still all connected together, and we are relatively happy and good to go. We can now add our dimension, change our dimension. This is completely optional depending on what you've researched or what you're trying to replicate. Now what you can see here is one of the relationships was not kept, so the chord has to be inputted as a horizontal part, otherwise those dimensions will just change the angle to still meet the requirement. Again, I left that there to highlight a potential common mistake. So now let's try again with that relationship back in. That's much better. If we leave that dimension in, we will be unable to change the angle of attack later on, so let's remove that. Now we've got the dimension. If we want to change that dimension at any point, we need to make sure we re-add that relationship. So angle of attack, we want to make sure that we can create a firm and fixed point, which we're going to use as the trailing edge because that's a single point, and all I've done is I've attached that single trailing edge point to the initial origin. And now I'm just going to add a construction line again, in which I can dimension our chord line versus the construction line, and that can give us the aerofoil's angle of attack. This will be a changeable dimension as always, so we can change the angle of attack quite simply in the initial sketch, and that will allow us to reproduce that throughout the whole model, so we can do multi angle of attack analysis at a later date. So now using our servicing tab, we can now extrude that sketch. So the extrusion for us in this case is going to be the core part of the rear wing. I've extruded in a single direction, worth noting, and also I have not added any end caps. When we create a solid from a surface, we need to make sure that it's all open throughout the middle, so I don't want any end caps. we fast tracked a little bit here, and I'm just adding on a very rough and ready end plate. So I pre-did the sketch and jumped ahead. So if I had an end plate, I can extrude that surface. Just be careful about which direction. It's only a thin section. We'll make sure we point outwards. We don't want the end plate overlapping the aero. And now I can go into the familiar function of boundaries, and I can start to add boundary surfaces to create the enclosed end plates. When I'm pressing, as you can see, it started to build it and then it disappeared. The reason for that is the surface tool needs you to follow a logical path. If it's not logical, it won't preview the surface. So let's start that again, one edge at a time in a common clockwise format. In this case, you go anti-clockwise as long as each individual edge that we are choosing is next to the next piece, then also it fills it, so we know we've cracked it. So the end plate is now capped, the inside is not, so we just need to make sure that we then do the same again. Now you might be thinking here, we need to make sure that the end plate also doesn't cover the inside of the aerofoil shape, because that will give the same fault as I just mentioned before in terms of not giving us a consistent surface to then stitch and create solid. So the boundary sketch will allow us to create something. Now if I actually go into this cut view, you can see it has also added a surface on the transition between aerofoil and end plate, which is absolutely not what we want. So we need to make sure as early as possible that we address these factors, otherwise we'll only end up with errors later on. None of these things are overly difficult to do, we just need to be cautious, and if we use the split functions for view, we can see exactly what we are and what we are not in for. So I'm just trying to make sure I create a view which I can then work with, because when it's kind of hidden on the inside, I need to be able to see it. So you can see part of this is hollow, part of it is not, which shows the boundary surface in part, not in full. So it allows me to select that when we do this trim function. So on the trim function, what is the thing, what's the shape that I want to replicate, and then what's the bit I want to remove, and it will quite quickly and easily trim that away from us. So now that end plate should be completely hollow and go all the way through to the other side of this wing section. So as long as that is all hollow and no surfaces intersect each other except for on the transition between one surface and another, then the stitch and solid function will work. So next we just need to replicate that. Now what I'm going to do here is I'm just going to try and whiz through a little bit of a test. So I've just capped that edge. Now if I select every surface which we've got, what I'm doing here is I'm just checking that the knit and create solid function is working. If it isn't, it means I've got an error somewhere that I need to fix. If it is working like it is, we can see from the cut section view, we're very happy that that section on that end has been done appropriately. As long as I mirror the way I've done that end on the other side, we will then create a solid aerofoil and end plate. So that's good. So we'll delete that, and now let's go and replicate that on the other side. So I'm going to import some new planes to make sure that I get the right dimensions. Being particularly careful here to where we create reference geometry and from where. There is some intricate detail. You could quite easily generate a plane 50 centimeter offset from a surface which is actually 3 or 5 millimeters offset from another plane, so then your 50 centimeters is actually just under 50, and it becomes a bit confusing and complicated. So just be really careful wherever possible using reference geometry as an initial plane that's set as the front plane in this case. I've gone to the midpoint because I might want to change the aerofoil shape through this extrude at a later date if we decide we want to try and create some kind of change in section. Then going on to the other side, we now have replicated the initial plane on the exact other end of the aerofoil. Just be a little bit cautious, make sure you've got the right dimensions. So now if I take over that sketch, so I've got my end plate sketch, we can then follow a very similar practice on the other end. We can create our extruded outer surface. Just making sure that everything's aligned. And just as before, we can now start to create some boundaries. Again, being careful with choosing the right edges. So this time around I'm going to start on the inside, because as you can see on the other side, using all of these different cut functions makes it a little bit complicated in seeing that inner edge. But in this case, it makes it quite easy and visible. So it's just a little trick. So again, choosing the aerofoil, which section do I want to keep and which section do I want to remove. I want to remove that end. So we should be able to look straight down to the other side, which is great. We've got the extruded end plate profile, so if I add a boundary onto that section, that should be quite simple to create a solid version from knitting this together. We now get the yellow boundary, so we now have what should be a completely hollow representation of the aerofoil. So let's try that. So make sure we select every single surface. It's a little bit confusing sometimes. Make sure you've definitely selected some of these finer surfaces, but it will select the whole boundary. Everything's in blue, so let's create a solid after we've stitched it together. And fingers crossed, if we do the cut view again, this should be a solid section. Now if you're going to do a dual element aerofoil, or more than dual, here's a couple of little tricks. So when we're in the initial sketch, so I've scrolled way back to the initial sketch, what we can actually do, well, we might sometimes mirror or convert entities onto different sketches or different planes. If I add a different point, and this point is the second aerofoil section's trailing edge pivot point, I can dimension that to be a distance away. So I've just come up with some numbers which feel like they're about right. Rather than trying to convert entities onto the same plane, which it doesn't really let you do, what we can actually do is a slightly different function. So if we see underneath convert entities, mirror entities, sorry, we can copy them. So it already pre-selected the point that I'd already raised. Now we can just click and drag rather than choose everything separately. So now we've got everything selected, including the dimension, which I don't want. So let's try that again. Carefully drag in, there we go. So that's the aerofoil. So actually you could choose something a bit more scientific with some precise start and stop. If I just choose any point, it will allow me to click and move it away. As long as all the dimensioning and the relationships that are in there are the same, which they are, then this is a perfectly appropriate way of doing it. So let's obviously the second element, much smaller. I'm not sure whether these dimensions are going to work at this point. It's a bit of trial and error, but there's nothing wrong with a bit of trial and error if we get it set up right. So angle of attack is usually more for the second element than the primary element. Attaching that trailing edge point to my new point set in space. Now I don't necessarily need to change the dimensions of my aerofoil, I can just change the distance in which that point is acting. I want to see an overlap. Now because I've then scrolled forward, that extrude is still valid. So all it's done this time is it's extruded both profiles. Now if I just move around my end plate to make sure that it fits both aerofoils, what I can do is just drag and drop, because I didn't over dimension this in the first place because it was a little bit more creative than specifically toleranced. It allows me to then update the end plate dimensions. If I drag this forward a little bit, all of the other actions in terms of the boundaries are the same. It's just the size of the thing which I'm creating a boundary on is different. And the only other thing that we need to make sure we're very careful of is the trim. When we trim that aerofoil section out, it will only allow us to do a trim on one aerofoil at a time, so we need to make sure we add an extra trim to cut out those extra pieces on the second element, because this point is still valid. So hopefully that helps you as a guide as to how to make the dual element aerofoil. Thanks for listening.